So I'm joining you here from Israel, and shalom, Boston. Shalom is the same word for hello and for peace. So an anecdote about Hebrew, and I want to start with really apologizing for not being there with you on stage in Boston as I planned. As you know, we're experiencing our let's say 9/11 here in Israel. So my place is now here with me and my family and my country. But I'd like to thank the organizers for not giving up on me and for showing their full support and for suggesting holding the talk virtually. So thank you, and thank you all, everyone, for accepting me, the DevOps Days community, the amazing community, for your support and solidarity. And as we say in Hebrew, toda. And with that, yeah. And with that, let's go to today's topic about observability and the data analytics paradigm shift. So let's start with this, and let's try and make it entertaining. Who's seen this Venn diagram definition from the presentation, definition of observability? Raise your hands. Come on. Let's make it interactive. Okay, most of you. Proof that it's not pre-recorded, that's live, people showing hands. And the aim of the talk is to tell you that no, that's not the definition of observability. And I'll tell you exactly why. So, as people said here, my name is Dotan Horovits. I'm based in Israel. I'm the principal developer advocate at logs.io. I won't be talking about logs.io much here, but you can find our folks there outside in the booth. So do check the booth out. Logs.io provides a cloud-native observability platform. So observability is definitely what I do for a living, also on my day job. In addition to the day job, I'm also a CNCF ambassador, the Cloud Native Computing Foundation. And I'm an organizer also of the DevOpsDays local chapter in Tel Aviv. So I'm very much familiar with DevOpsDays. I'm also involved in the local CNCF chapter with Kubernetes Communities Days and many others. These are the things I want people to know Israel for, the startup nation, not what we see now. And I also run a podcast in English called Open Observability Talks about open source, DevOps, observability. So if you're interested in these topics, do check it out. And in general, you can find me everywhere at Horovits, Horovits. So do feel free to reach out if you have questions, although I'm not there with you in Boston. And let's start talking about observability. So I told you that's not observability, but what is observability is about? Let's go back to the formal definition of observability, which I don't know if everyone knows, but it's actually taken from control theory, so essentially from applied math. It's not even from software science, which says that observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. And I hate this definition of observability, and I'll tell you why soon. But first, let's understand this definition of observability. So when talking about software systems, what are these external outputs? So these external outputs is essentially the telemetry that our systems emit, the primarily metrics, traces, and logs, the well-known 3 pillars of observability. And I hate this term 3 pillars as well, and I'll tell you why soon on that as well. But first, let's understand these 3 pillars because they are important. Logs, metrics, traces, these are the telemetry signals, very important ones, that help us understand what happened, where it happened, and why it happened in our system. Okay, so if suddenly I have an endpoint that is non-responsive, a 404, or is very slow to respond, suddenly login takes a second or a couple of seconds, the metrics will probably help me detect the issue, maybe the alerts that I put on top of that. And then logs will help me diagnose the issue and tell me why it happened, because let's be frank, developers put a lot of information in the logs about what goes on in the system. And then traces help us isolate the issues and tell us where it happened. If you think about a distributed system, microservices, each request goes through many interacting microservices, maybe also backend services. So being able to pinpoint and put a finger on where exactly that latency is coming from, that's what traces is about. So indeed, these telemetry signals are very important for gaining observability. However, they are by themselves not observability. In fact, I see it day in and day out with my users and with other community members. Many organizations collect all these signals and still end up with broken observability. And actually, who found himself in the middle of an incident with poor observability, even with all these telemetry? Raise your hands. Come on, let's do another example. Okay, so look around you. You can see I'm not alone here. And the question is, why is that? So let's go back to the classic definition. The classic definition puts great emphasis on the external outputs, the signals that our systems emit, which are essentially the raw data. The other important elements in that definition are too often overlooked: the inference process, the insights. So I personally use a different definition of observability for software systems. So behold the new definition. Observability is the capability to allow a human to ask and answer questions about the system. Okay? The capability to allow a human to ask and answer questions about the system. So, and why do I like this definition so much? First, I like it because it makes it very clear that observability is a property of the system. You can't bolt it on in the aftermath like in traditional monitoring. You should incorporate observability as part of your system design as a first-level citizen from day one. That's what many people call observability-driven development. And I'll show later how to do it in practice. So that's one. The second reason I like this definition for observability better is that it makes it very clear that observability is essentially a data analytics problem. So the more questions we can ask and answer about the system, the more observability is. Okay? The more questions we can ask and answer, the more observability is. Simple as that. So going back to logs, metrics, traces, that's just the raw data. We're interested in the insights, in understanding what goes on in our system. And this also calls for a different mindset, not the reactive monitoring and maintenance mindset, but a data analyst mindset to proactively query to get the right insights from the system. We need to be able to ask ad hoc questions, ones that arise when handling incidents we haven't anticipated or seen before. Many people call it the unknown unknowns, okay? So this is the data analytics paradigm shift in observability, and that's the topic for today's talk. So what is observability really about? I'd like to go over several important points you should consider in your observability practice in a data analytics mindset. And there's quite a bit to cover about observability, about collecting different data from different sources, formats, and types, about structured, standardized data, enriching, correlating data, and many more. I hope the time permits to cover it all, but let's dive right into them one by one. Observability is about collecting data from different sources, formats, and types. So metrics, logs, and traces are the classic signals, but there's no reason to limit ourselves just for logs, metrics, and traces. I know that we humans tend to favor the rule of three, but there's nothing holy in this trinity. That's why I hate the term three pillars. Other signal types may be required to gain observability, and we need to be flexible to incorporate these new types of raw data. Here are a few tweets from the past couple of years. People started talking about four signals from MLT, metrics, logs, and traces, starting to talk about MELT, adding events to the mix. That's a tweet by Alolita Sharma, a senior at Apple and on the CNCF governance committee, now previously at AWS. And then I saw Yuri Shkuro, the creator of Jaeger, open source distributed tracing, and now he's at Meta. Back then in the day, it was at Uber. Talking about 6 signals, aptly abbreviated as Temple, adding exceptions and profiles. So let's not limit ourselves to just 3. And actually, continuous profiling, the profiles in particular, seem to gain a lot of momentum. We see many new entrants to the space. I'm actually curious, who here knows what continuous profiling is, with a show of hands? Okay, so not many. And just out of curiosity, who uses continuous profiling in his system today? Okay, okay. That's at least the ones who know actually put it into practice, which is great. So just for those who don't know, continuous profiling is like the classic profiling, like I don't know, pprof or other tools that you know from Java, .NET, or others that but done in an ongoing, in a continuous fashion, which makes it an excellent way to see where we spend most of our CPU or memory, where out of memory comes from, to map performance down to the specific functions or even specific lines of code. In this example in the slide, you can see a flame graph of improving RabbitMQ performance with profiling. So it's a very powerful tool. And it's a nice complementary to metrics, logs, and traces. I'll share a lot of links on this talk so you can follow up. So here's the one. Check out this QR code, the article, if you want to learn more about continuous profiling and how it fits in the observability stack. That's recommended. And I'm glad to say that OpenTelemetry also identified continuous profiling as a key signal to add. A year ago, we had the initial extension proposal. A lot of work has been done since. And a fresh update from last month, the data model for profiling is already out there, along with prototype implementations of the client libraries and the collector. It's quite influenced by pprof, for those who know this tool. And for those who don't know OpenTelemetry, don't worry, I'll talk more about OpenTelemetry in a few slides, but just wanted to share these exciting updates. But it's not just about signal types, but also about data sources. Observability involves the ingestion of signals from many different data sources across different tiers, frameworks, and programming languages. So you may need to monitor I don't know, a Node.js front-end app, a Java backend, a Postgres, a Kafka cluster, a Redis cache, and maybe even a few cloud services. That's quite typical. And consistently collecting these heterogeneous data across so many different signal types, sources, formats, programming languages has been a serious challenge for many years. And as each programming language and each vendor and each open source tool has its own way of instrumenting, exposing, and collecting telemetry. And that's not just an operational headache and vendor locking issue. What's the main pain? Remember, we're talking about data analytics mindset. The main pain is that it creates data silos. It makes it very difficult to correlate data across these data silos and ask cross-cutting questions, which is what observability is about, right? And that's what OpenTelemetry comes to solve. OpenTelemetry is a major game changer in that respect. I actually gave a whole talk about OpenTelemetry at KubeCon last year, but just in a nutshell, OpenTelemetry is an open source framework for generating and collecting telemetry data across different signal types and data sources in a vendor agnostic unified manner. It's a project under the CNCF, the Cloud Native Computing Foundation. So as a CNCF ambassador, I'm also very proud of this project. It's the second most active project in the CNCF today after Kubernetes itself. So very impressive. And in the picture here, you can see the architecture of the OpenTelemetry collector. As you can see, it's built like a typical data processing pipeline with receivers in multiple protocols, then processing and aggregation, and then exporters in multiple protocols. So you can collect telemetry from your app, backend, frontend, or from other infrastructure components. You have receivers for Kubernetes, Docker, Kafka, MySQL, Redis, the AWS X-Ray, GCP PubSub, CollectD, a lot of them. And then different processes to do things such as filter, modify, batch, sample, and so on. And you can change processors to get more elaborate processing logic. And then you have exporters, depending on where you ship your data to in the backend, exporters for many backends. So an AWS X-Ray exporter, Azure Monitor, Google, logs.io, Prometheus, Jaeger, Zipkin, Kafka, whatnot. So really a very powerful collector. And besides the collector, which is the green part here in the middle in this diagram, OpenTelemetry also offers client libraries for instrumenting applications in multiple programming languages. That's the blue part on the left, and an OTLP protocol to uniformly transmit the telemetry, general purpose telemetry data delivery protocol, and more pieces. You can check out the QR code that you see here on the slide for guide to OpenTelemetry, including sub-guides per programming language. So to get you up and going with a hello world in Java, .NET, Node.js, Ruby, Python, and more. Definitely a whole world, but very interesting to check it out. Observability is about structured, standardized data. Who still has these kinds of unstructured plain text logs in his system? Be frank. Come on, raise your hands. Okay, so I'm not alone in this one either. And I'm here to tell you, don't. Forget about unstructured plain text logs in flat files. Okay, no human is going to read through your mounts of log lines to extract insights. As we said, we're running a data analytics shop here. So data needs to be structured and in a machine-readable format such as JSON, protobuf, so we can use software to analyze it at scale. So the first best practice in this regard, send structured logs. And remember, observability is a property of your system. We need to apply observability-driven development. Put thought into your schema to make sure that all the relevant data within your logs is modeled. In this example, you can see structured log from astronomy shop, having the classic log level type, which is essentially the microservice name, Docker, env ID, timestamp, the things that you'd expect. So use structured logs. And also make sure you use consistent conventions, okay? Not calling it service ID with a capital I here and service underscore ID in somewhere else and component ID, and here it's type. Apply observability-driven development, use consistently. Actually, in large organizations, platform engineering helps to create these cross-organization conventions and can even provide abstraction layers that add these uniformly and consistently, so developers don't deal with that at all. So I have a whole talk about platform engineering separately, but definitely keep it in mind if you have this practice at home. So this is a good start. But we said we have many third-party tools, right? So how do you make sure the same data model and semantic conventions are followed across the different telemetry sources and formats? So one of the OpenTelemetry's goals is actually to standardize on a structured, strongly typed, machine-readable log format. And an exciting update from, from very recently, Elastic Common Schema, ECS, announced merging into OpenTelemetry. So all the knowledge, the aggregated knowledge from the Elasticsearch community, the Elksta community about log analytics, is going to become part of OpenTelemetry semantic conventions for logging. So that's on the logging side. On the metrics side, we have OpenMetrics, which is the Prometheus-originated metrics format. And today, it's pretty much a de facto standard. Many common tools, frameworks expose out-of-the-box metrics in this format. Kafka, RabbitMQ, MongoDB, MySQL, Elasticsearch, Jenkins, Jira, Docker, cloud services like AWS ECS and Azure Health. Whatever you use, check, you most likely have that already out of the box. And another exciting news about that, there's work to make it an official IETF standard. There's an open RFC for that. Check out the QR code for more information about these open standards and the recent updates. Really exciting stuff on converging the community. Observability is about enriching and correlating data. Data enrichment is also an important step in data analytics. And adding metadata, such as in this example here that you can see, I added the user ID and the build number to the previous example for your logs, can greatly help map the log to the root cause. Just think about a customer-specific issue or a problematic build version and how easy it is to root cause with the additional information. And remember, effective data enrichment can turn your logs into more meaningful events. We also use data enrichment to support correlation between signals. A common best practice is to add a trace ID as a metadata to all the logs to enable easy log trace correlation. So this part I think many already know. But even better, you can emit your application logs as part of the trace data instead of emitting two different telemetry types. If you think about it, your application emits logs and then it emits spans, which are like logs. So why not combine, right? For those who don't know, a trace, which is like graphically what you see on the right-hand side, the Gantt chart, a trace is comprised of spans, the bars on the Gantt chart. Each span is the individual operation in the request execution sequence. So the front-end service and the operation HTTP GET / customer, I don't know. So we can output the logs as part of the span context. So they are inherently contextualized to that specific span in the trace, to that specific operation of that specific request execution flow. Another best practice is to add exemplars on metrics to enable metric trace correlation, which is essentially to attach the trace ID for easy jump from a metric to the sample trace. So, and I'm glad to say both Prometheus and OpenTelemetry projects have been enhanced to support exemplars as well as many other tools. So definitely check out whatever stack you use for exemplars. It can be very powerful. Observability is about unified query and visualization. So far, we've talked about ingesting and storing the data in a conventional form, which is a good start. Next, we need a way to easily ask and answer ad hoc questions about our system, right? This is the essence of observability, as we said. The problem is that we don't want to look at different screens, like the visual that you see on the slide, and use different query languages with each one. The data analytics paradigm shift requires the ability to query data from the different sources to draw the relationships, right? But the reality is that the market today is quite fragmented. We have Lucene for logs, PromQL for metrics, maybe InfluxQL if you work with InfluxDB. We have LogQL and many others. We have vendor-specific ones like NRQL for New Relic, DQL for Dynatrace. This fragmentation is a problem for data analytics. Again, a point of light here, a new working group under the CNCF, under the Technical Advisory Group for Observability of the Cloud Native Computing Foundation, was formed to standardize on a query language for observability. I actually covered it on my podcast, Open Observability Talk. So if you are interested in this initiative, check out the QR code to learn more. But it is a very nascent initiative. It's just the beginning, but it's a good start. The other thing is that we also need a similar unification on visualization side, and we're still farther away on this front. One very interesting initiative is Persis, which is a very interesting new open source. It had a lot of buzz just a couple of weeks ago at PromCon Europe that was held in Berlin, for those who were following PromCon. And it's talking about dashboard as code, GitOps friendly, and many other things. I actually hosted the creator of Persis also on my on this month's episode. So you're welcome to subscribe. It will come out next week. But as it currently stands, we do not have an industry standard for unified query and visualization. So the best practice is create your own organizational standards to make sure that you can query across data types and visualize them together as much as you can, depending on your stack and your application, the programming language, and so on. And by the way, also here, platform engineering can be of great help in standardizing and creating these organizational standards for query and visualization. Observability is about data volumes and data to noise ratio. Like in any big data analytics case, you quickly find that your data volumes explode and become expensive to scale out. I'm sure that many of you have seen that. How many of you encountered the volume problem with observability? Yeah, so it's becoming painful, whether you do it yourself with your own open source or with definitely with vendors that provide the service. And last month, I was at Container Days, and someone shared the survey stats, said that 99% of the indexed observability data is never searched. 99%. So this is the noise to data ratio, okay? And as we said, observability is a property of your system. So apply observability-driven development to carefully consider the value of your data. So let's look at some best practices around this. And let's start with logs, okay? Logs are very verbose and storage intensive. So think which logs you really use in real time for troubleshooting and which ones you don't really need. Okay, think, I don't know, debug logs, for instance. Don't keep the low value logs if you don't need them. And if they're used just for rare compliance and audit cases, store them in maybe an S3 or similar cheap storage, but not on your primary observability store. In the worst case, maybe you can fetch them in and analyze them on your main tool or directly on S3. It doesn't matter depending on your tool and capabilities, but definitely not paying the price of the real time for just compliance and audits. And if you don't need the logs, ask yourself if these logs are just used as a metric, such as observing the frequency of HTTP status codes, like in this Kibana visualization on the slide. Log data like this can actually be rolled up into metrics, time series data, rather than keeping the raw logs. You anyway watch the metric graph and not the raw log lines, right? And for logs that you do see need to keep as raw logs for troubleshooting, how long do you need to keep them for? What's a real retention you require? Okay, according to stats, again, stats that I've seen even last month, and I see that day in and day out at logs.io, the company I work at, most operation logs are queried only a few days back. So think also about the retention and which logs you really need to keep and for how long, okay? So that was about logs. Now let's talk about metrics, okay? Metrics are just numerical data points, so people tend to think of them as cheap to store, but they exponentially build up with high cardinality. So a few cost factors to consider. First, the high cardinality. With each incident you investigate, you should, the typical thing, you discover a new failure mode that you didn't plan on, you need to track, and after the postmortem, the retrospective, developers go and add metrics and the labels to increase the observability coverage for these cases. But this results in an increasing number of labels and dimensions, which is essentially high cardinality, okay? So you need to think about the labels you need for your metrics, because high cardinality metrics are exponentially expensive. And it's not just about the number of dimensions, the number of labels, but also about the range, okay? The size of these dimensions, okay? When you think about a dimension like, I don't know, the cloud regions, then you have maybe 10, 20 EU, US East 1, US East 2, Central, whatnot, that's fine. But if you go to wide range values, or maybe even open-ended range values, like, I don't know, adding user ID as a label, this is an anti-pattern, okay? And can drive your data volume up very quickly. Another issue is collecting but not using, okay? In most organizations, the vast majority of metrics aren't actually used. In Kubernetes environments, 75% of the metrics are never put to use in any dashboards or alert rules. And that's because there's a bloat of metrics, out-of-the-box metrics in Kubernetes, and people just use the defaults rather than considering what they really need, okay? And that's also what I see among our users and customers at logs.io. In fact, we created a tool to monitor this usage. The screenshot you see here is logs.io's data optimization hub. You can actually see an example here, a metric with 22 labels, taking up 0.6% of all the data volume that is flagged not used. So no dashboards, no alert rules, nothing, okay? So observability, again, observability data driven development, think what you need. And check out this QR code for an article I wrote about the cost factors you should be aware of when working with metrics data. It's part of my Metrics Essential series with lots of best practices and metrics and monitoring. So I elaborate more on these, but definitely worthwhile checking. So I want to leave some time for questions. So I want to summarize. I know it was a lot of information. So let's just go over the main things. First, remember that observability is a data analytics problem. My definition, I hope you adopt it and spread the word. Observability is the capability to allow a human to ask and answer questions about the system. By the way, the QR code is from an article I wrote a year ago to Inside Big Data about this topic. A lot of more information there if you want. But just to summarize, observability is about collecting data of different sources, formats, and types. We talked about not just logs, metrics, and traces, but other signal types like profiling. We talked about different data sources and formats and programming languages. We talked about observability being a structured, standardized data. So forget about the unstructured plain text logs in flat files. Look for structured machine-readable logs. We talked about observability being enriching and correlating data, to add metadata to turn your logs into meaningful events, to add metadata for cross-signal correlation, like trace ID to logs, exemplars to metrics. We talked about unified query visualization to reduce the number of query languages and different visualizations tools you need to ask cross-cutting questions. We talked about data volume and data to noise ratio. Think which logs you need for which need. Also think about the labels you need in the metrics. And remember that high cardinality metrics are exponentially expensive. So you have more information here in this QR code. And with that, I want to thank you, and may the open source be with you.
All right, awesome. Anyone have any questions? We'll see. We might need to proxy, see how this all goes. But anyone have any questions?
Come on, who's the brave one to ask? Show people that it's real life and not recorded.
Awesome, in the back. I'm coming to you. If you don't mind using the mic, we can make sure Dotan hears.
So one of the things you went over was some of these logs are never used, and there's the principle of the black swan event where, we don't think we'll ever run into this problem, and then it happens. And so I think there's a human nature of that fear of, well, what if the worst happens? Could you talk a little bit on how what you can do to counteract those fears to say, yep, no, this is really something we can throw out. It's not going to impact things.
Yeah. I think I got the most of it about the fear that you say, okay, don't keep all the logs, but some of the logs you never know, and there's the fear of deleting or not saving. Is that the question? Yes. Yeah. So it's very valid, and actually this fear of dropping things, but also with metrics, people keep the out of the box because they fear to remove things that are the defaults. I see that day in and day out. The thing is that, as I said, you don't need to altogether drop them, like delete them. There are middle grounds. Many vendors, I can tell you, for example, at logs.io, you can save it in cold tier, and then you have a warm tier. Some other vendors also have these sorts of tiered approach that you can choose. Some vendors even let you pull that back into your main memory and use the core tools to analyze if you do find the need. So this allows you for balance. But there are clear-cut cases, like I see customers even persisting debug logs. So you need that's the observability-driven development, that you need to exercise some logic and also look backwards on what you used in the past. If you haven't used it in the past couple of years, it's probably not something that you tend to use in troubleshooting. That's a guideline, I would say.
All right, I think we can sneak in one more question. If anyone, we also have a mic up top. If anyone in the balcony has a question, someone in the back. All right. Coming over. We'll use the mic just to make sure Dotan can hear you. All right. Thank you.
Hi, my question's real straightforward. Would you be able to make the QR code larger that points to the working group around a standard query language for observability? That was a little small here, and my phone was struggling to pick it up, and that's very exciting.
Dotan, if you send it to me, you can throw it in the Slack. Sorry.
So first of all, yeah, I'll gladly put this on Slack and some other links that you'll find useful, and it's very exciting. It's a new working group. It started less than a year ago, and lots of traction around that. And if you are passionate about this topic and you have something to contribute, it's open source. It's a CNCF Cloud Native Computing Foundation. So again, being a CNCF ambassador, you're all welcome. It's on the CNCF Slack in a work group called Observability Standardization or something like that. So you can all join their bi-weekly calls, and you're more than welcome to chime in and help us determine what's the right path forward on this one. So really exciting, and hoping to see maybe some of you getting involved there.
Thank you very much, Dotan. Let's give him a big round of applause.
Thank you very much, everyone.